Hi, my name is Dr. Tishan. In this video, we're going to write equations of lines in 3 space. So before we write equations of lines in 3 dimensions, let's review from algebra class how we write the equation of a line in 2 dimensions in an XY plane. When we're writing the equation of a line, think back in algebra, we need to know the direction the line is going in, and we need to know what a point is on that line. So the direction the line is going with, we achieve that by finding the slope of the line, and then you need a point on the line. Okay, so back in algebra class, write the equation of a line. We needed a slope and a point on that line, so the direction and a point on that line. So now let's move to 3 space, in 3 dimension, a three coordinate system. What do we need in 3 space? Same idea. We need the direction the line is going in, and we need a point on that line. But in 3 space, the direction the line is going in is represented as a vector. So we'll have to find the vector representation of the direction of the line, and then we'll have to use a point on that line to write the equation, and you'll see how that'll come together. In addition to that, algebra class, do you remember you have all those forms for equations of lines? You can write your equation of a line in slope-intercept form. You can write the equation of a line in point-slope form. You can write the equation of a line in general form, standard form. We had so many forms to write the equation of a line. The same idea, same thing is coming at you here in 3 space. In 3 space, you have parametric form, and we have vector form, we have symmetric form. So there are lots of forms to write the equation of a line. But all in all, we need to know the direction the line is going in, and we need a point on that line. So take a look at the XYZ plane over here. Let's take a look at the XYZ plane. And I have a line drawn on this plane in green. There's line L on this plane. All right, and so we want to, and then on this line L, I have point P labeled as x sub 0, y sub 0, z sub 0. I have point Q labeled x, y, z, and I drew vector PQ in red so you can see that here. Okay, also on this diagram we have a vector V. Our vector V, the direction numbers in vector V would be A, B, and C. All right, so we have line L that's going through point P, and we have a parallel vector V with direction numbers A, B, and C on the diagram, okay? And so vector V is in the direction of line L, they're parallel. All right, so let's go ahead and see if we can derive the parametric form of equations, okay? So take a look here, based off of this diagram, from the diagram, vector PQ is parallel to vector V. So we have to take that as a given here. Vector PQ and vector V are parallel to each other. Okay, same direction, they don't have to hold the magnitude, they don't have to be the same length, but same direction, they're parallel to each other. Now, vector PQ, if I wanted to write vector PQ in component form, if I wanted to take vector PQ and write it in component form, then I would have to take x minus x sub 0 for the first direction number, then y minus y sub 0 for this direction number, and then z minus z sub 0 for that direction number. This is how I would write it in component form. This takes my vector PQ and it moves vector PQ down here. So it's like on top of V, but not necessarily the same length as V, vector V. So now, we have vector PQ now written in component form, and because vector PQ and vector V are parallel to each other, they are scalar multiples, so we can write vector PQ as a scalar multiple of vector V. By definition, parallel vectors are scalar multiples of one another, with T being our scalar here, okay? So now what can we do? Well, vector V, we called vector V ABC. The direction numbers in vector V are ABC, is how we're defining it here, okay? You can take a scalar, one of your properties of vectors, you can take a scalar and move the scalar inside the vector. So you can write vector PQ as A times T, B times T, C times T, okay? So you can see step by step this coming together. So now we have a name for vector PQ up here written in component form, all right? And we have another name for vector PQ down here written as the application with the parallel vector. And so since vector PQ here and vector PQ here, we can take the direction numbers inside. We can set this equal, we can set them equal, we can set them equal. So you can take the direction numbers, x minus x naught equals A times T, solve for x, and you have this expression. Y minus y naught equals B times T. y minus y naught is b times t. Add y naught to both sides, y equals y naught plus b times t. And then you can take your z minus z naught equals c times t. Okay, take your direction numbers, set them equal. And so what does this generate here? This is where your parametric form comes from. This is parametric form of your equation of a line. Parametric because you're introducing that parameter of t inside of the equation. So x equals x naught plus a times t, y equals y naught plus b times t, z equals z naught plus c times t, and that is your parametric form. To write symmetric form, you could just take t, subtract your initial point, okay, and then divide both sides by the direction number from vector v. You'll have t equals t equals t equals, and because you have t equals in terms of x, in terms of y, and in terms of z, you can set those pieces equal to each other, and it's over right here on the screen. Right? You can also write a vector form of the equation. Looking at the diagram, you could also use the concept of addition of vectors. You can call this vector r naught in here, vector r in here. So this vector equals this one plus that one using your vector notation. So vector r would equal vector r naught plus technically vector pq, but vector pq is t times vector v. So that's where the other forms come from. You have your parametric equations, your symmetric equations, and your vector equation. Three ways to write the equation of a line in three space, in three dimensions. So let's look at an example. A lot of times in an algebra class, what do you use for examples? In an algebra class, they'll give you 2 points, right? So 2 points, and you'd have to find the direction and then use a point, write the equation of a line given 2 points. We're going to do an example, same concept, okay? Same concept. So what if you were given 2 points? Let's say we're given 2 points in our three space, okay? And we're given 2 points, and we want to write the equation. And we'll write the equations today in parametric form, okay? So the first example, we're going to find the parametric equation. Find parametric equation. Okay, for the line. Okay, so we're going to be given 2 points. Our first point is going to be -8, +1, +4. And our next point is going to be 3, -2, 4. 3, -2, 4. Okay? So these are our 2 points. And we want to write the equation of a line. Just like you did in an Algebra 1 class, they give you 2 points, write the equation of a line. Same idea here, but now the 2 points we're given, they're ordered triples, aren't they? Because we need our x we need our x and our y and our z. Okay, so I'll call this x sub 0, y sub 0, z sub 0. We'll count, that'll be our initial point, and then we'll call this x, y, and z. All right, so we have a line, and I'm labeling it this way because that's the way I presented it over here. So we have a line, and we have 2 points down the line. So we have one of the points, x sub 0, y sub 0, z sub 0, and we have the other point is x, y, z. So what do we need to do? Well, we need to find the direction the line is going in. We need to find the direction. All right, so, and we're going to call the direction, we're going to use v for our parallel vector. So to find the direction the line is going in, let's go ahead, and so 3 minus a -8, okay, and then -2 minus 1, and 4 minus 4. When we simplify, because we're getting our parallel vector that we need for this equation, 3 minus a -8, that's 11. -2 minus 1 is a -3, and 4 minus 4 is 0. So here is the direction the line is going. This is our vector, all right? So we want to write the equation of the line. So we are going to take our point, -8, 1, 4. We're going to take this point because that's our x sub 0, y sub 0, z sub 0. We're going to take this point. All right, and we're going to take our vector, which we claim to be 11, -3, and 0. Okay, so here is our point, and here is our direction, and we write the equation in parametric form. So what is the parametric form again? It's going to be x equals x sub 0, so -8 plus 11 times t. All right, your y would be 1, okay, minus 3 times t, and then your z would be 4 plus 0 times t if you need to write that, okay? So this is your equation in parametric form. Here is your equation of the line in parametric form. Okay, so there's the equation in parametric form. This is how you would write the equation of a line in parametric form in 3 space. All right, so why don't we, one more example. Let's just do one more quick example. All right, same idea. Given 2 points, we'll write the equation of the line in 3 space. So let me erase here. All right, erase here. And let's do one more example before we finish this video. So let's use 2 points again. So 4, -1, 2. So 4, -1, 2. That's one of our points, okay? And the other point, let's use 1, 1, 5. 1, 1, 5. We have 2 points in an XYZ 3-dimensional system here. We have 2 points, 2 ordered triples, right? Because we need the X and the Y and the Z coordinate. And let's go ahead and write the parametric form of the equations of the lines that pass through these 2 points, okay? So we'll call this our initial point X sub 0, Y sub 0, Z sub 0, and we'll call this point our X, Y, and Z. To write the equation, we need direction and we need a point, just like you learned in an algebra class, and it carries right over. We need direction, we need a point, okay? The direction is going to be our parallel vector, which is this vector written in component form, so we need direction. Okay, now how do we find the direction, right? We go this X minus X naught, so it's 1 minus 4, okay? Y minus Y naught, so 1 minus a -1, Z minus Z naught, 5 minus 2. All right, so let's set up our parallel vector. So compute, so -3, 1 minus a -1, positive 2, 5 minus 2 is 3. So there's our vector, okay? So we have our point. Right, the point we're going to use is 4, -1, 2. All right, and then we have our vector. Okay, the direction the line is going in is -3, positive 2, positive 3. So let's go ahead and write the equation in parametric form. So X equals our X coordinate, okay, minus 3 times T, the direction in the X. All right, Y equals -1. Plus 2 times T. Z equals 2. Our point, Z sub 0, which is 2. And then plus 3 times T. So here is the equation, parametric form of the equation of the line in 3 space through these 2 points, okay? All right, so this is just an introduction of writing equations of a line given 2 points, parametric form, and I hope this helps. If these videos that I'm making do help, please consider subscribing to my channel. There's a subscribe button just down below, so please consider subscribing. Thank you for watching, and I appreciate it. All right, bye-bye.